Hi there, and again welcome. We're still looking at the alkanes and how they are made. How they are named. And in this video I'm going to look at a few additional details. Okay, the first thing I want to do is talk about the condensed structural formula. So the condensed structural formula. Okay, so the condensed structural formula is, if I were to take the structural formula which we looked at, the structural formula, for example, let's go for butane. Butane, BUT is for 4 carbons. Okay, the AIM tells me they're all single bonded. Okay, so there's my 4 carbons. They're all single bonded, which means the rest of them the rest of the bonds are hydrogen bonds, and for time's sake I'm going to leave out writing the hydrogens. Okay, but you shouldn't, please draw in your hydrogens always. This is the structural formula for butane. 4 carbons single bonded, and hydrogens are the other covalent bonds. Now the condensed structural formula takes each of these carbons and describes them with all of their bonds. So for example, my first carbon has 3 hydrogen bonds, my second carbon has 2 hydrogen bonds, my next one has another 2 hydrogen bonds, and my final one has again 3 hydrogen bonds. This is the condensed structural formula. So you'll literally take each carbon and describe it with the bonds that they have. Now what I want to look at in this next video is, or in this video, is complicating this process a little bit by adding, instead of having normal butane, what if one of these didn't bond with a hydrogen but bonded with another carbon? This is not a double bond, these are 2 single bonds. Okay, so now what we've got is we've messed a little bit with the symmetry here, but this is called a branch. This is called a branch, or you could also call it a substituent. Now a substituent is kind of an alkane structure. In other words, it's only single bonded carbons filled up with hydrogens. Okay, that's what I mean by an alkane structure. And but it forms a branch. It is not part of the main chain. It's shorter than the main chain. But as soon as we have a branch, this is called an instead of an alkane, this is an alkyl. An alkyl group. That's another functional group called the alkyl functional groups, and alkyls are alkane structured branches. Okay, so they break off from the main chain. Now what will happen with the naming of this thing? Because now obviously something needs to change. Okay, well, the moment it's not a standard structure anymore, we need to number our carbons. So what we will do is we will try and find the longest carbon chain. So in this case, you can start really anywhere you want and find any carbon chain. So I can start and find this. Here's a carbon chain here. Can you see me highlighting it? There's a carbon chain there. You could have chosen this carbon chain. It's got 4 carbons in. Okay, and obviously I'm only considering one string. I don't break off into here. But I could have also looked at this carbon chain here. I could have taken it. Let's actually use a different color to demonstrate it. Here's another carbon chain. Could have chosen it if you wanted to. It wouldn't have made a difference. Okay, you'll still see that if I chose this first one, the purple one, the second carbon is the one with the carbon chain. Okay, if I were to choose this light blue one, again it's the second carbon that has this growth on him. Okay, so it doesn't matter which one you choose. What you will do is you'll start on the end that has the most carbon, that's the closest to the carbon chain. So we'll number the carbons so that where I would put my carbon chain would be the smallest number possible. So this would be carbon number 1, carbon number 2, 3, 4 if I were to use this carbon chain. If I were to use the purple carbon chain, I would number it number 1, 2, 3, 4. Notice how it's the same one that has the branch. Okay, so it doesn't matter which way as long as you choose a single chain. As soon as we've numbered them, that number would tell me where I need to name my alkyl. Okay, so what I do is I know this is a butane, so I can write it as butane. Why is it a butane? Because it has 4 carbons in its longest chain. But it's not just a butane, it is a methyl butane. Methyl, spelled like this. Can you see this alkyl, the il coming in to that? Methyl butane means I have a branch, an alkyl branch, and that branch has only 1. That's what meth stands for. Meth stands for 1. Let's quickly go through them again. We've got meth, eth for 2, prop, but, pent, hex, hept, and I'm only going to go to oct for now. Okay, oct. Okay, they would tell me 1, 2, 3, 4, 5, 6, 7, or 8. This obviously you need to study off by heart. You need to know them in your sleep actually. So we have meth representing 1. So this will tell me my methyl, my alkyl branch has a single carbon in it. Okay, and now in front of this methyl I just need to indicate which carbon gets this chain. Okay, it can never be the first carbon, because if it's the first carbon it would have just made this a propane. Okay, not a propane, a pentane. It would have had 5 carbons in its longest chain if it's 1. So this can never be a 1. Okay, it can only be a 2 or a 3, because either if I were to add a branch at number 1, I would just be extending the chain. If I add a branch at number 4, it would just be extending the chain. So this would only be a 2. This is a 2-methyl butane. Why? Well, what does this mean? This means my second carbon has a single carbon alkyl group, and that it belongs to a 4-carbon single bond carbon chain. that's a lot of words, but that's how much information is contained in the name, and it's a brilliant, very simple system that always works. And this is called UI pack naming. Okay, this whole system, I should have mentioned this earlier, I'm sorry. This is the UI pack naming system, a standard that we use to name organic compounds. Okay, so before we continue to what I wanted to say next is, let's quickly look at the condensed structural formula for 2-methyl butane. Okay, the 2-methyl butane means that my first carbon I know will have 3 hydrogens. Okay, there you can see 1, 2, 3. My second carbon will have 1 hydrogen, and then it has a branch. So to indicate branches, we will put that in brackets. Okay, so if I've got 1 branch, and this branch has a single carbon with 3 hydrogens in it, and then I can move on to my carbon number 3. Carbon 3 looks like that. Carbon 4 looks like that again. Okay, let's quickly look at the molecular formula. Remember, molecular formula simply counts the number of every element. We've got 1, 2, 3, 4, 5. We've got 5 carbons, and we have 3, 4, 7, 8, 9, 10, 11, 12. We've got 12 hydrogens. And now I want you to notice that it is the exact same general formula that we had for all of the alkanes, and that was, the general formula was, for every carbon I have 2 hydrogens plus another 2. So even if I were to add how many branches I want to, as long as they're normal alkyl branches, okay, I will have the exact same molecular formula. Okay, now I did mention before that the moment I were to add this one to number 1 or number 4, I would simply be extending the chain. This now would just become a pentane instead of a methane with a methyl branch to it. Okay, so what I want to show you is that if I had rather had CH3CH2, in other words, I'm going to have pentane here. Here's my pentane. 1, 2, 3, 4, 5 carbons, and a total of 3, 6, 2, 4, 6, 12. So here again I've got 5 carbons and 12 hydrogens. Exactly the same molecular formula for both of these. The moment I have the same molecular formula for 2 different substances, these are 2 different substances, these are called isotopes. Isotopes. So what is an isotope? Substances with identical molecular, let's move up a bit so you can read, molecular formulas. Okay, so this is very important, so please take note of it. It often comes up in questions, is to find the 2 isotopes, of the 2 elements that are isotopes of each other, and then it literally means you need to find the molecular formula, and you need to find the other ones in the molecular formula that has exactly the same number of elements of each type in them. Okay, so let us look at just another example to illustrate the whole process. And sorry, there's some. Okay, so I'm going to literally just draw a random one here. So let's say we've got, I think 4 works nice. We've got a butane here. Okay, but on number 2 and on number 3 we now have carbon chains. So here I've got a carbon chain, and there I've got another carbon chain. Now this one actually changes things. I didn't think of that, but it does. Okay, so here is my carbons. All the rest are hydrogen, so please forgive me for not writing them in order to save your time. Okay, so the first thing we need to do in order to name the substance, so they give us the condensed structural formula, we need to name them. Let us find our longest carbon chain. So here we have a carbon chain of 4, but if instead at this point, instead of going on, if I just went down, okay, I would have a 1, 2, 3, 4, 5. So this would be pentane. Okay, but this pentane has 2 carbon chains, 2 branches to it. Okay, now the 2 chains are both methyl chains, so I would call it methyl pentane. But because there are 2, I need to put a di in front of them, telling us we've got 2 dimethylpentane. You'll remember this di comes from our covalent bonds that we were talking about before, naming binary covalent bonds. We have mono, which we usually do not write, di, which represents 2, tri, which represents 3, tetra, representing 4, penta, representing 5, and etc. If you can't remember that, please refer back to that. So dimethylpentane means I've got 2 methyl branches to a pentane structure. Now again, we just number. We need to give the numbers where we find those methyls. And so if I were to number this chain, I would start numbering from the side that has the closest branch. So I can go 1, 2, 3, 4, 5, or if I go from this side, I would have had to number it like this: 1, 2, 3, 4, 5. So here I can see number 2, the second carbon has a chain, or if I number from the back, the third carbon. So obviously I choose the side with the closest carbon. So if I do number from this side, okay, I see my second carbon and my third carbon has the chains. So in order to include that in the name, I would say second and third dimethylpentane. Okay, so this was not exactly what I wanted to show you. So let me just complicate it slightly by adding another carbon to this process. Now I can see whether I go from 1, 2, 3, 4, 5 this way, or 1, 2, 3 and then down 4, 5. It doesn't matter. Either way, the third carbon has a branch to it, and this branch now doesn't just have a single carbon but 2 carbons. So how will we name this one? Again, we can simply see the longest chain is 5, so this is still a pentane. Okay, but this time I've got both a methyl and an ethyl chain to it. Now when we have the more than one alkyl group, okay, we will write them in alphabetical order. Okay, so we've got a methyl and we've got an ethyl. Ethyl will come first because in the alphabet E is before M. So the ethyl group, that's the 2,1, is on the third carbon. So this would be 3-ethyl. Okay, the methyl group is on the second one, so that would be 2-methyl pentane. Okay, so the final thing I just wanted to say is that if we go back to our previous example where we had only 2 and it was both of them were the same, if we were to have, remember, if I have a carbon, here's an example. Let's take a simple 3 this way and 3 this way. Okay, carbons, 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 carbons. Now you can see my second carbon, okay, the only one that could have, the second carbon actually has 2. So the way I would name this is I would say, no matter which way you choose your 3 carbons, both in any way, even if I go this way, it is always the second carbon that has 2 methyl groups. So this one will be 2, 2, because there's 2, we'll say dimethyl, and then 3 is propane. Okay, so I just wanted to show you here, we will just number twice when there are, if it's the same number and it's a di, there's 2 methyl groups on the same carbon, then we'll just write that number twice in commas. Well, thank you very much for watching. This was a long video, and at least it forms a solid foundation for a lot of the others as well, so they should go quicker. But thank you very much for sticking it out to now, and in the next couple of videos I'll try and do a few examples just to solidify your understanding of this. So I hope to see you there. Goodbye.